Yeah. I think I don't know. It's 11:02. We can start. My name's Brian Glas. I actually live in Chattanooga. So this is the first time in my life I've actually been able to go speak at a conference and go home before dark to my bed, which is like I'm really excited about. I get the distinction, dubious honor, whatever, of coming after Chris Roberts and standing between you and barbecue. So I will do what I can not to go long. Basically, what I'm going to try and talk through today is I had the privilege of being part of the top 10 leadership team for 2017, working on some of the data analytics and such. And so I'm going to give you a little bit of background of the story of what happened through the top 10, but then also, to be honest, what the top 10 used that data collection for was just a minuscule piece of what was actually in that data. So I want to go through, try and talk about some of the stuff, insights, analytics, and things that were within that data that we collected. Because we basically, by the end of the day, we have one of the largest publicly available collections of vulnerability data. So, how many people actually know that the top 10 first issued in 2003? Most people know of it starting in 04, and then 7 and 10, and as we go through that whole setup. Initially, they actually planned to do it annually. They did 2003, then they did 2004, and they're like, yeah, no. And so they went to 3-year cycles. It started as an awareness document. We needed something when we were building AppSec. We needed something to point people to and say, hey, we know it's overwhelming. What are the top 10 things? Because top 10 things are popular, right? David Letterman, top 10. That used to be like one of the biggest things you would wait to watch on TV at night. But now it went from an awareness document to getting embedded in the PCI. It's now a standard to some extent. And so it has this weird dual purpose in life where at one point it's like, hey, if you're going to do anything, this is the baseline of where you start. But then it's also, hey, by the way, if you're really have to adhere to compliance, this is what you absolutely have to do. And unfortunately, some companies take it as, once I get there, I'm good. And then, unfortunately, we have a bunch of vendors that are like, we can test everything in the top 10, which is actually kind of impossible. But they don't tell you that because they can't tell you that because in the last 10 years, it has become the standard that you can't actually bring a product to market unless it can test against the top 10. So it got interesting. So in April of 2017, top 10 tried to go out in 2016. The leadership at the time didn't have the time to be able to actually get it. It was basically a one-man band trying to do all of it. He didn't get it out in 2016, so we finally got the release candidate in 2017. Had 2 new categories for that year. A7, insufficient attack protection, and A10, underprotected APIs. It didn't take long for it to get ugly. There was a major backlash from it, more so than had been in previous top 10s. The problem was, and it wasn't that people necessarily disagreed with the root of what these things were trying to get to. The problem was the way it was written up, it sounded like to do A7, you essentially need a WAF or RASP. You either need that runtime application security protection or you need some web app firewall. And then APIs was kind of weird because we kind of always assumed APIs were applications and that they were part of everything else, but they were like, these are unique. And then people started going, well, what about microservices? Or what about, any other sort of architectural nomenclature for a different kind of application? Why aren't those in the top 10? So a lot of people with a lot of complaints, accusations of bias, because unfortunately one of the guys that was one of the leads actually ran a company that would have benefited from you buying some of those tools to solve A7. So from my perspective, I used to work with the guys who were the leaders of A10, or leaders of the top 10. I had some insight in how things were built and such. And I kind of got tired of everyone just complaining, but nobody actually taking the time to step up to solve something. So really what I set out to do is like, all right, I want to go figure out what happened, and I want to write a sane, neutral, balanced blog post on the process of building the OWASP Top 10. So once I went through that, I realized there's a whole lot more here, and I ended up writing a second post on doing some basic analysis of the initial data call. And so it spiraled from there, as you'll see really quick. So the initial data collection for the top 10, the design was to be full public attribution, which means everything you contributed was linked back to your company, who you were and all, which was, admirable because they wanted like full disclosure and full transparency. The problem is the only people who can contribute in that environment are third parties. No company, right, in this current litigious society that we have, no company is going to divulge their own internal vulnerability data. I was working for Microsoft's Trustworthy Computing at the time in 2016 when it came out, and I was like, hey, I've never seen Microsoft contribute to OWASP. Can we get vulnerability data from internal testing and actually contribute to the top 10? And they're like, oh yeah, that sounds like a great idea. We're all about helping out. And if you hadn't noticed, Microsoft seriously changed over the last 5 years. It's pretty amazing. And so I got data together. I had about 500,000 records of things that they had tested and found and fixed that never made it to production. And I'm getting ready to putting the final touches on it, and one of the executives was like, wait a minute, is that going to be public? I'm like, yeah, I've kind of told you that the whole way. And they're like, yeah, we can't do that. I'm like, come on, take that risk. And he's like, no, it takes one person writing one blog post saying how terrible Microsoft is because they had 500,000 vulnerabilities in their software. And it's like, it just died. And it's like, if there had been some way to do it in some level of anonymous basis, that data might have been able to be contributed to the top 10. Your question? Just thinking. So, and also as well, if you've got questions, ask. I mean, I've got stuff to talk through, but I have no problem stopping to answer questions or whatnot. So basically what happens is all the data contributors become vendors and consultants because they can hide their customers in the full aggregation of data. So, I mean, you've got Veracode who will test, how many hundreds upon hundreds of companies' software. So when they give you just basic numbers and statistics, you have no idea which customer it is, and it's essentially obfuscated. The hope is to, by 2020, come up with a better way to do data collection. And to be honest, we need to come up with it by the end of 2018 to make sure people can get things together. Because one of the other big problems, and we'll talk about it later, is people don't collect data and store it and categorize it and catalog it in the same way at all. So one of the things I ran into really quickly when I started looking at the original data that was sent was we had basically two forms fall out. We had the human augmented tools, which was basically somebody ran a tool, and a human may or may not have looked at the results and may or may not have filtered the results. But it is absolutely, at the core of it, it's a tool-based scan or test. Then there's the tool augmented humans. So if you do human pen testing, you almost always use some level of tooling. It might be open source, it might be paid for, but you use something. It might be Burp, it might be Zap, it might be Nmap, SQL Map, all sorts of fun stuff. There's some serious differences between what's actually identified as vulnerabilities and the way things are reported between when a human does these kind of security tests and a tool does these security tests. One of the big ones is frequency of finding. When a human goes through and does a test in an application, they are typically seriously time-boxed. So a company is like, I'm willing to pay you X number of dollars for X amount of your time. Or you do internally, which is you also, even though you're not paying a third party, the internal people don't have 6 months to test an application. You get a week, maybe 2, depending on the size. So if a human finds cross-site scripting, they're going to be like, I found it in 3 places, I'm going to call it systemic, and I'm done. You have cross-site scripting, I need to move on to the next thing. When a tool does it, it's like, ha! I found 6,000 places in your code that this same pattern exists, and I will give you 6,000 findings for it. And you end up with a ream of paper if you attempt to print the report. So it's very difficult to compare those two numbers in terms of how bad was cross-site scripting. Context, or lack thereof. Humans understand context. When we test an application, we know, hey, this is bad because we understand this 9-digit number is a social security number because we understand where in the form it is, we recognize the data format, we understand the page. I worked at FedEx for a decade. We had an automated tool that gave us critical findings on essentially every single test because it found a serious plethora of 9-digit numbers. FedEx is in the business of shipping. Do you know what 9-digit number is incredibly common when shipping? A zip plus 4. But a tool has no idea what the context is, so it does not understand that, hey, if this number is in a field called zip or zip code or sitting next to a state and a city, it's probably not a social security number. But a human picks that up immediately. We have not yet taught tools how to understand context. Plus, humans have a tendency to go off script. The best pen testers I know are the ones that are like ridiculously creative. And they're like, yeah, I know that's the path, but what's this do? And they wander all over the place. The biggest challenge for human pen testers is consistency. I've got some absolutely brilliant people I work with, but getting them to have this consistent baseline of saying, like, it doesn't matter which of the 6 of you tested this, I need to make sure I can tell the client that this base set of tests are covered, is the real challenge. Tools are really good at that because they don't go off script. They will only do what you tell them to do. But humans don't scale, which is why we get into the automation, which is why we're getting into this DevOps setup where we're like, we have to run a ton of tests at speed because humans can't possibly keep up with testing all of the different things we're doing. So it became an interesting setup. And actually, I'm really glad you all are actually sitting this close because you can actually sort of see this. So in the initial data that came out, I found that there was essentially 4 companies that were tool-based with humans playing with it. One that was pure tool, and the rest of them were humans that used tools to test. Notice the difference in number of findings per application. So even though these 2 companies up here, identified themselves as combined manual, expert code review, and pen testing with free tools. If you have 62 instances of vulnerabilities identified per app, you're running off of a tool's output. You're not running off of a human's output. So it made it really interesting to classify that. So then I'm like, how do you compare these numbers to each other? Because the top 10 had been built by prevalence. So prevalence essentially mapped to frequency, like how many things are identified. And so the tools totally overwhelm. So the other thing I looked at is I wanted to see of the particular CWEs we were trying to look at within the top 10, who was better at finding which? Is it humans or is it tools? And so everything that's highlighted in orange, the humans had a sizable larger percentage of the total findings. They could find those better than the tools. Dark gray, where the tools were definitely better than the humans. And then the ones in white were the ones that's kind of 50-50. It's pretty much in the middle. So I'm looking at this, I'm like, man, humans are terrible. I was like, how do we get to the point where tools find so much more than we do? And then I started realizing it. I'm like, because this is frequency data, the tools actually did 10 times the number of applications the humans did in this particular data set. So I was like, all right, so let's pretend we found 10 times as many humans who can actually do work. And we're all, at least some base level of decent testing. So I bumped the humans up 10 times. I said, all right, let's just standard baseline, let's 10x the number of humans who actually did the tests and the applications. And all of a sudden, the whole thing changed. And you're like, all of a sudden, humans are ridiculously better at machines if you could scale them at being able to find this kind of stuff. And so right now, the biggest problem we have is humans struggle to take what they have inherently learned in their head and be able to apply it to a tool to teach it how to do stuff that we know how to do. That was one of the big challenges when I was working at Microsoft. We were trying to come up with how do we make, you may have seen it, it's called DevSkim. So it's essentially a plugin for an IDE that's kind of a security spell checker. So the idea is while the developer's typing, if he accidentally types in, I'm going to do a hash of MD5, it'll flag it immediately and be like, company policy, no MD5, you need to pick a different hash algorithm, pick this one. Writing the rules for that is actually ridiculously difficult. So you're like, oh, that's easy, and you come up with about a dozen of them and you hit a brick wall. And you're like, now what? And we have the same problem when you look at static analysis scanners, dynamic analysis scanners, things where you have to write a test case that says this is what you need to look for. I've talked to a couple of companies, they're like, we have incredibly brilliant people who understand the language at a level that they could do this. We can't pay them enough money to actually sit down and do it. Because nobody wants to sit down and write those test cases. It's horrible work. The problem is we don't scale without it. And so we've got this catch-22. The other thing that we're running into is the technologies are getting so complicated that fewer and fewer people actually understand how things work under the covers. Back 10, 15 years ago when you were like, we have Java, we have .NET, and we have a couple of other things. We had a larger percentage of developers and even security people who really understand how the language works. So that way you could do better code analysis. Now we invent a new language every week, and developers have all of this great stuff built on top because basically we found there's a limited number of developers in the world who can actually understand how to code, and we needed more than that. So we said, all right, we're going to build all of these multiple layers over the code so a lot of people who would never be developers can now be developers because they can learn how to actually interact with some layer 4 levels above the code. The problem is they really don't know how to troubleshoot and they don't know how to, what's actually happening in the code if they have to look at it. Yeah?
Do you think some of the DevOps angle of having full stack developers can help that though? Like people maybe waking up a bit?
Maybe. Maybe. My concern is, though, that they have to build more layers to allow them to keep up with everything, and they're no longer just focused on coding. They now have to pay attention to, hey, I've never had to set up a Docker container in AWS before. I'll pick that one. And there's a whole sidetrack for DevOps in terms of we took the people who finally understood how to do all of the infrastructure stuff, and we said, hey, we don't need you, the developers can figure it out. And so we're going through a whole new cycle of developers have really no idea what they're doing in that space. I would like to, but I think we're moving too fast. I don't think we can get back to, hey, we're going to have a core set of people who really legitimately understand how all this works. So out of curiosity, I said, hey, if I looked at all the tool stuff and I looked at the prevalence of what tools find, what am I going to get? Guess what? Cross-site scripting. We can find it. We know how to find it. We're good at finding it. It happens a lot. The problem with cross-site scripting is you have essentially two scenarios. One, we had protections in place and somebody missed it in a couple places. And two, we have no idea we're supposed to protect against it. And we have 5,000 to 8,000 instances in an application. Typically, it's one of the two. Still has SQL injection. How do we still have SQL injection? It's like 10, 15 years we've known how to fix it. It's a rhetorical question. I know why we still have SQL injection, because we still, today, build languages that have backdoors that allow you to do pure dynamic queries because we can't figure out how to write a nice, safe way to do it that handles every possible way you might actually want to write a query. And there are times that you still need to have dynamic. The problem is developers get frustrated trying to figure things out, and they're like, hey, there's a backdoor, and I can just write a straight-up query. The interesting thing is when you look at humans, humans are much better at finding a broader range of things. And we're good at finding things like misconfigurations and authentication and authorization and a lot of stuff that requires knowing context. So we're getting there, but so I went through all this, wrote these blog posts, and then a little while later, has anybody heard of the OWASP summit? So last year, in June, outside of London in the UK, there was the OWASP summit. It's actually amazing. There's one in 2018. It's not official OWASP summit. It's called the Open Security Summit. I would highly recommend attending if you can. It is not a conference. It is a working working project summit. You go, you start at like 8:30 in the morning, and you go until you can't keep your eyes open. And for a week, you focus on a particular project. I was going because I was one of the co-leads for SAM, which is the Software Assurance Maturity Model. So I love SAM. I love talking about SAM, but it's meat and potatoes. So it's not sexy enough to get into a lot of conferences. Most of my SAM talks get turned down because they're like, this isn't some cool red team hacky thing. This is, oh, we need to fix our stuff and understand what we're doing. And yeah, we're bored with that. So based on all of the social media outcry from RC1 and all things falling apart, the existing leadership was like, we're done. We're tired. We've been doing this for 14 years, and we're just done. And so they contacted Andrew Vanderstock, and they're like, hey, we know you've been in OWASP for forever, so would you mind at least temporarily taking on the leadership role of Top 10? So I was already there. They had Top 10 working sessions, and so the whole thing fell out really quick, and they were like, hey, by the way, you probably didn't realize this, but you did more data analysis on the Top 10 data than anybody has yet to date. I'm like, oh, I wrote a blog post. They're like, nope, you've done more than everyone else. So I was like, wait a minute. So would you mind helping us with data analysis for the Top 10? Because we want to try and get it right. Because at this point, OWASP had taken a pretty nasty black eye, and they wanted to like rebuild trust. Not just the Top 10, but OWASP as an organization. I'm like, all right, I'm a sucker for that kind of stuff. So at the summit, we came up with a new plan. So we needed to expand the data call. We ended up with over 100,000 applications by the time we were done. It was amazing. And while we didn't disagree with the concept of that the original leadership was trying to do, is like, if the Top 10 is always built off of data, it's always looking behind you. It is always data that's 1 to 2 years old, and we'll always be playing catch up. So we made a decision that said, hey, at least, or up to 2 of the categories will be picked by industry professionals. So we're going to do that the best way we know how, and that's to make a survey on the internet. So we did that, and then we were like, basically, we're going to move this to GitHub. So what had happened is when I did the research on the process and stuff, there was essentially no visibility into the development of the Top 10. I went through the history of all of the release candidates to finals, and not one of them had changed a category. There had never been enough discussion or enough complaints or adjustments or whatever to ever change a category from an RC1 to final. A couple of them got rearranged one year, but they had never actually changed any of them. So we made the decision, we're like, all right, we're going to do it on GitHub. People can do issues. You can see everything we're doing. For better or worse, you can see everything we're doing. The other thing that worked in our favor for that was then now the translators can get into this a whole lot faster. So the Top 10 has a major global reach. And so, but then you run into things like if I talk to a couple of people from France and they're like, yeah, unless you write this in French, the French developers won't touch it. It's like if it's not in their native language, it's not important enough for them to pay attention to. So for this kind of reach for the Top 10, it has to be globalized. So we made a call out, and we have, I think the Japanese and the Spanish are both done already, which is amazingly quick. They were actually done some odd months ago. Considering the Top 10 was released right before Thanksgiving, that's amazingly quick for what's in there. Hebrew, Korean, and so on. I don't think I have them all, but they're getting there. So the industry survey. So we built this survey. We basically took all of the CWEs from the previous couple Top 10s, and we're like, all right, these things were always identified as on the cusp, important, but not part of the Top 10. We're like, all right, made this list, made a nice Google form survey, start advertising on Twitter. Within 24 hours, one person's like, how do you know somebody's not going to mess it up? Cheat the system. I was like, thanks. That's great. Thanks for introducing the concept to somebody where they're like, yay, I think I'm going to mess with the survey system for the Top 10. But thankfully, nobody did. I think one of the advantages was you couldn't see how things were rating. So you didn't know how many submissions were made to the survey. So if you were attempting to game the system, you would have to guess, and you would either come up short to where what you were trying to influence didn't happen, or you go way overboard if you misguessed how many submissions would be in there, and it would be super obvious that you would have this massive spike in favor of a particular type. So we wanted the survey to be anonymous, so we didn't require email addresses or anything, so that way, but we also could, at that point, couldn't require that people only vote once. So I actually made a chart because I like playing with data and making charts. So I made a chart of the submission pattern because I wanted to see, is there any weird anomalies in the submission pattern? And honestly, no, because this was the initial call on Twitter, this was the follow-up on Twitter, this was the next follow-up on Twitter, and this was the beseeching people at the very end to actually do that. So it was almost all pure grassroots, Twitter, LinkedIn. We did get a press release out. Unfortunately, it went out on Memorial Day. Kind of disappeared, but... So we had 550 people respond, which was awesome. I was amazed at that, absolutely. I was like, all right, if we get to 200, I can probably accept the results. And we got up to 550. So what it came down to was like number one, and this was like Equifax time frame, right? So exposure of private information, absolutely, that's the most important thing. Because we asked people to rank them. What's your top 4 things you think should be in the top 10? In privacy, and then cryptographic failures. So what we did is we looked at it and we're like, hey, we have a sensitive data exposure category in the top 10 already. So basically we beefed it up to account for those two. So sensitive data exposure from 2013 to 2017, same name, different content. If you look closely at the actual content and the focus of it, it is more toward privacy violations and crypto failures. Deserialization of trusted data. Guess what? That's number 8 now. IDOR is essentially an access control issue. So we rolled it in the broken access control, just made sure it was called out well. And then after that, insufficient logging and monitoring. So we got a little flack for this one because it's technically in and of itself probably not a vulnerability. Because we're not talking about me taking control of your system through your logging. We're talking about the fact that you have no idea I was ever there. And if you look at how long it takes to detect breaches and how few people actually watch their stuff, we're like, look, we've got to bring a light to this at this point. I mean, how many times, if you've ever done an assessment, could you say, hey, you never caught me. Hey, you never had a log. Hey, you never. And so half the customers I have, they're like, yeah, we log. I'm like, who looks at them? We log. Like, when do you look at them? It's like, do you wait till somebody on Twitter tells you to look at them? Or, so the one that I'm curious about and I want to watch, because I think this is going to get bigger, inclusion of functionality from untrusted control sphere, which is a nice, heavy academic way of saying you included somebody else's JavaScript in your site. And then more than that, but really it's third-party content. And if you look at how much information is bleeding out of websites today based on tracking and analytical software stuff that people load on their site because they think it's super cool to see these graphs of what people are doing on their site, all that stuff's getting farmed out. We had a test once where it was a sensitive HR app, and all the queries for what people were searching for were GET queries, so they were part of that request. And the analytics was shipping off everything in the URL to see like the clickstream of where they were going, but it also identified the user and what they were searching for and that stuff. And it's like, that's not good, guys. So I'm expecting that one's going to keep going up, to be honest. And also SSRF got a bump, I'm fairly certain, because there was a nice exploit at DEF CON in that time frame. It's kind of funny how you can go back and see some of that stuff. But in the results, so one of the biggest changes we made is going from frequency to incidence rate. Like I've said before, there's no way to compare what a tool can find and a human can find on frequency. You just can't. So we looked at incidence rate. And so basically we changed to say, Did you find something one or more times in an application? Yes or no? I don't care if it's systemic, I don't care if it's a one-off, but did you ever find cross-site scripting in an app? So a machine gets a vote of 1 and a human gets a vote of 1. You can't go any farther than that. So, also, somehow we managed to get data, more data from Veracode, and then redone into the format of incidence rate instead of frequency. Check marks. How many people know Fortify is not HP anymore? Okay, so HP spun off HP Enterprises, which sold the software to Security Focus. Fortify is no longer HP, it is Security Focus. Anyway, I had to put Fortify in there because otherwise most people don't know what I was talking about. Synopsis, and then Bug Crowd. And I'll talk about Bug Crowd in a little bit because that one's actually fascinating on its own. So now we have incidence rate. So fascinatingly enough, we went from 90-some% cross-site scripting to all of a sudden it's not the most prevalent thing you find anymore. So basically what this is saying is of 114,000 applications, 25% of them had security misconfiguration. 25% of them had cross-site scripting. 10% had SQL injection. Yeah?
So when you see this, I mean, when you say that, it's like, yeah, that makes total sense. You have some kind of visceral or some kind of data reaction like, well, duh, we all know security misconfigurations. Why wasn't it showing that? So you feel like I'm on the right track or something like that?
So this more aligned, yeah, absolutely. This more aligned with like, I've been doing this for like 12 years. Yeah, and I'm looking at this, I'm like, I buy this data. I can absolutely relate to it because I see it's like, you know, I've got clear text transmission of data, XXE. Some people are good at finding XXE. Some people never look for it. It gets interesting. I'll show you in a second. Oh yeah, I tried to make it bigger. These were my backups just in case like I had little screens and nobody could see stuff. If you've never used Morph on O365 for PowerPoint, it's awesome. It lets you do things like this so you can actually see. And people aren't in the back going like, that's great, but I can't actually see what you're trying to talk about. So the other interesting thing about this is when they made the call for the top 10 data, the original leads fixed a set of CWEs they were interested in. So for all I know, there are some other stuff that is found that is not in this list because it was never asked for. And that's something, again, for the next time around, trying to figure out how to resolve this. Because when I asked for data from Fortify, they're like, we'll send you that subset that you want. But by the way, here's everything else. And it was a list that's 4 times longer than this. And so the other thing is mapping to CWEs. Not everybody does that. Actually, very few people do that. HP, well, I'm not sure it's HP anymore, but HP has their 7 kingdoms. They're like, we don't like CWEs. They had some folks over there, and they're like, we're going to make our 7 kingdoms of how we categorize vulnerabilities. So CWEs aren't perfect, but dang, I don't want to build another one. I'd rather fix this. This is like fascinating to me. So I highlighted everything in green that actually has data. So these are basically the largest contributors. This is about 83% of the applications that are that were submitted. So you can see you've got Micro Focus, you've got check marks, you've got Bug Crowd, 3 different years of Veracode data, Synopsis, and Softtech. So when you look at it this way, you find all sorts of things. So remember security misconfiguration? We hadn't really seen it before, and all of a sudden it's over cross-site scripting. Go look at Veracode, 2014. They never looked for it. 2015, never looked for it. 2016, they wrote tests to look for it. Holy cow. 43% of the applications that they now started looking for have it. And all of a sudden it is now one of the most prevalent things. So a lot of what we're running into is we're not testing for everything. We're only testing for subsets of things we know about. Look back through like missing authorization. So Veracode's realized that there's a few tests they can run now that they can actually kind of start to find some kind of authorization. They're also starting to find IDORs. I'm not picking on Veracode. Veracode I have great appreciation for because they were actually willing, Tim Jarrett was willing to go through the effort to give me incidence rates for 3 years that will actually show you what they test and not test for, which is just absolutely fascinating to me. I have great respect for them for being willing to do that. And BugCrowd as well, because we went back and forth with BugCrowd for a while, and they're like, Bug Bounty right now is a super competitive marketplace, and we are really hesitant to divulge the data that we have because HackerOne and some of the other startups could try and take advantage of it. But at the end of the day, they're like, you know what, this is the right thing to do, and we're going to do it. And so in like the 11th hour, BugCrowd submitted the data they had for the previous year. So basically, because this is incidence rate, the numbers in here are of 46,260 applications, 20,059 actually had that vulnerability. I don't know how many times, but I know it had at least one instance of that vulnerability. So, and some of these are like, I don't know, like, and I'll get to it in a minute. There's a lot of nuances in that data that I just don't know. I don't know how many times the same app might have been tested. I don't know how purely unique these vulnerabilities are. The other thing that runs into interesting is BugCrowd. So BugCrowd, being the nature of its business, is probably the most highly accurate data I have in here because a company paid for it. So all the rest of it, like they ran scans or they ran tests and they got data back and they said it's verified. But with BugCrowd, a human found it and a company paid them for it. So in terms of being confident of the accuracy of that data, that is where my highest confidence level is in that BugCrowd data. Now the interesting thing is if you notice their percentage for cross-site scripting is at 100%, and their count of applications is 635. I had to make that up because they don't know. So BugCrowd was like, hey, we can give you the data. And I was like, well, how many applications is this incidence rate over? And they're like, we don't know. I was like, what do you mean? They're like, well, honestly, we can't tell you how many different applications our testers have tested. So I realized it's a totally different data problem because they have numbers, but they can't tell you out of what population. So I basically had to pick, well, I've got to put a stake in the ground somewhere, so I'll put cross-site script, I'll make whatever the highest number is that's the number of applications, because that's all I have to go on. Outside of that, it's a pure guess, and I don't have a basis for a number. So this is also interesting. So I tried to break it down a little bit different way. So this is the percentage of the 44 submitting organizations. What percentage of them actually found at least one of these in one application in their entire data set? So 96% of the companies that submitted stuff. Now also understand, I had companies that submitted from Veracode with 46,000 for a particular year. I had one company submit one. We tested one application, and this was what we found. And it was amazing because, I mean, I had some global, like some companies from South America and some from Indonesia and just all over the world. But you look at the things that we're good at finding. We're good at finding CSRF. Humans can find missing authorization, some crypto misconfigurations, and then old school path traversal, SQL injection, authentication. It's usually just lack thereof. But then you look at the things that we're okay with finding. We can find some of these things. But then you find the things that we're just not very good at finding. The list keeps going on. But, I mean, we don't look for it. The interesting thing is I found that for the companies that looked for XXE, they found it. So if you had it, you actually had a decent percentage of finding it. But if you go back to the full Excel chart, full Excel graph that I was showing you, if you don't look for it, you don't find it. And there's a ton of companies that just simply don't know to look for it. And so XXE ended up getting into the top 10. Not everybody was happy with that. But a bunch went in because, one, it got a very high rating on the survey, and two, we actually had data to the support that if you looked for it, you would find it. So we've covered some of this. I mean, humans are better at finding diverse stuff. Tools can only look what they know about. So you can't do one or the other. You have to do both. You really do. And I wish we could get better at having the humans teach the tools how to do things. But like I said, that's a major struggle right now. So what this data can't tell us, I would love to be able to answer all these questions, but I want to know whether particular languages or frameworks are more susceptible to different vulnerabilities. I want to be able to tell a dev team, hey, you want to pick Go? These are the top 10 things you need to worry about writing an app in Go. Or if you want .NET Core, these are the top 10 things I need you to care about in .NET Core. Because right now we just have this super high level of, these are 10 things across the globe that we kind of think are bad, but some languages fix 4 of them.
Since you're in dialogue with these different companies, are you telling them or giving them suggestions that these are things that they should start trying?
So that's one of the things we're working on, is we're trying to, now that we have like these relationships with the different companies that submitted before, the hope is by the end of this year we have some kind of general agreed upon framework or structure that we can try and recommend people start holding their data in that format. So that, because if I wait to the call, for the data call for the top 10 2020, it's too late. It's probably too late already, just because of how slow and how long it takes people to do things. But I mean, it takes a lot of overhead. I've worked at a number of different consultancies. Trying to capture that is a pain. Unless it's part of your general workflow and it's the way you do business, you're not going to catch it.
It was interesting, the one that had the 3 years of data, how each year the percentage went down as if it was getting better, but they also doubled the number of applications too.
Yep.
So it wasn't just like they did the same application year after year, they added, like I said, double in size.
Yeah, I mean, yeah, it's fascinating watching that, but I can't build a trend off of that because now I know your business is doing great. You've added a 60 to 80% increase in apps every year, but I can't tell whether things are better or not because some apps are getting better and some are adding all new stuff. Sorry, did you have a question?
Oh, so I was just, does this ever extend to operating systems? You always hear, oh, Mac OS is better than Linux, better than Windows. And that's sort of making me think, unless you have real data, that's called specious claims.
Most of that right now is people's personal experiences.
Or just what you tripped over.
Yeah.
Which is the same thing.
Yep.
You said, yeah.
Pretty much. There's probably some metrics in there. I haven't found them. I've been more focused on app than OS.
But then it also be skewed by popularity. I mean, Windows is getting beat up more because there's more of them or something.
Well, no, and that's true because it's a better target. It's a better return on investment for hackers. And to be honest, people like to think, oh, hacker sits in the basement, he's got 24/7. No, he doesn't. Hacker still has limited time frames. They need to eat. They need money to get food to eat, so they are going to pick what they think is a high return on their investment. That's why there's so many more exploits for Windows than Mac, is because your user base is much broader. Your chances of getting a much better return on the time you put into it, that's why they look at that. Mac gets more popular, Mac gets more issues. It's just economics. I mean, even to the hacker level, it's economics. I mean, developer training, how effective? I'll talk about that in a little bit because it's I'm getting more and more clients trying to be like, help us figure out how to tie developer training effectiveness to actual code. Because it's great that they can answer the multiple choice test right at the end, but I have no idea if that translates into better secure software. So I wanted to real quick touch on vulnerability patterns you would want to see in production versus test. So we're getting into finding a lot more in test, and people have a tendency to treat that the same as production. So I just made this for fun. There's no real data behind it. But the idea is like what you would probably see is, hey, we instituted a testing process. Oh, crud, we have a ton of problems. All right, so we're testing, and we're doing better, and somebody decided they didn't want to follow the process, so you end up with a little hiccup in your vulnerabilities in production. But your idea is you want to tail off, and you're never going to hit 0 because we're human. We make mistakes. Things get through the process. We need to update the process because it's flawed. When you look at the test level, you could have that same kind of thing. All right, we put automation in our testing cycle. Yay! And we improved. But then we implemented a new language. All right, we figured out how to do something with that. Hey, new frameworks. And then this will never get down here. It never should, because you should find it here. You should find it at the test level, not the production level. This will allow this to happen. So, I mean, you talked a little bit about data structures. I mean, tell me when it was found. Tell me what language or framework it's related to. This is getting really hard to do with apps that have 147 dependent libraries in 6 different languages. When? Is it the same app? Have I seen the same thing over and over again? Because if I'm going to run automated tests on every build, guess what? I have massive duplication of findings. Can you boil that down? Does anyone know that CWSS exists? So CVSS, everyone knows what that is, right? Common vulnerability. There is a counterpart. He has a brother. It's CWSS. It's actually, in many ways, a better scoring system for the way we do AppSec related to weaknesses. I've been digging into that like crazy. It's actually, at my company, we're looking at shifting off of CVSS to CWSS. And so, like, this is what I was talking about before, about trying to, where in here are you finding the data so that you can pipe that data back into your process. And you can be like, hey, we've been catching stuff at this point in the life cycle. Can we catch it earlier? Or was it introduced since the last time we were doing something? Start pulling that back and trying to figure out, because nobody's done a study. 2002 was the last NIST study that was done where they tried to calculate cost of fixing defects at different stages of the software development lifecycle. Unfortunately, nobody's done an actual legitimate study since 2002 on those costs. I would love to dearly see it. I've been trying to talk my management or somebody into helping sponsor, pay for a legitimate industry study to try and identify, because that was waterfall. So given Agile, given DevOps, what's the cost in different stages to fix something? Because, right, if you have an architectural flaw that's in the design, you can't fix it in code. You can't code yourself out of a bad design. That is an incredibly expensive flaw. But if it's just an implementation bug, that's a cheap flaw to fix. And the earlier you fix it, the better, obviously, because you didn't build more stuff around it, and you don't have to. The farther you have to backtrack to fix something, the more expensive it gets.
So it's sort of a corollary to that. Have you seen any data in your travels through everything that, as we went to more of a Scrum kind of mode versus a waterfall, since there's more changes, there's more vulnerabilities?
I haven't.
I think we're better at that because we're paying more attention to taking smaller bites.
I've seen it both ways. That's the problem. Is I've seen it of we've done less security because we have to move faster. So security didn't figure out how to get into that pipeline, and so stuff's getting churned out. Plus the mentality of, hey, we load twice a day, we'll fix it. The problem is if you lose the data, you can't fix that on the next cycle. The data's gone. So yeah, you can fix the vulnerability as long as it didn't result into something larger. Waterfall, we took longer. We had more QA. So there were some benefits to waterfall. The problem was you couldn't pivot near fast enough to what the business said. And part of that problem really came into the business was terrible at describing what they actually wanted. So it really came down to as humans, we are terrible about writing requirements. We absolutely are. Being able to articulate that.
So it's going bankrupt versus getting a disease because you don't wash your hands.
Well, think about it, right? So you test at the end of a cycle. So you have this app, you've promised your customers, everything goes live in a week. Somebody finds an absolutely critical vulnerability. You have now left the business with two choices. One, 100% chance of failure by not deploying the app when you said you were going to deploy it, or some not really quantifiable chance of a breach, which may have some unquantifiable impact on the company. Which one are you going to pick from a business? You're not going to pick the 100% failure. You're going to launch the thing.
But you are doing the Russian roulette thing.
Yeah. I mean, you put the business in a terrible position. The idea is, as security folks, we should never get to that point. That test right before production or the test after production should be nothing but verification that you did all the other stuff correctly. That should not be the first time. By the way, we're going to introduce you into security. So if you look at how do you measure training, Simon? How do you measure training? Like, is it pre-test, post-test? Good job. People have good short-term memories, and they've learned how to do tests. They've been trained through the school system how to do tests. It has no bearing, really, on whether or not there's secure coding. Some people will take that training and actually apply it, and some won't. And really the differences seem to come from business pressures and other supporting environments. Do they have an IDE with plugins that help support whether or not they're doing secure development? If they have no supporting stuff other than an annual training, you get very minuscule benefits. Except for, and there's always like a standard bell curve, right? So you have a set of extraordinary individuals that are fascinated by this stuff, and they will fix it on their own. You have this huge 70, 80% set of people who are like, I got to get stuff done. I'm paid to make things work. And then you have 10% that just won't get it. They just won't. I wish they would, but they won't always. If you have an issue, can you track it to the dev? Can you understand who's contributing to more of your vulnerabilities? Do they need some kind of special training? I mean, because it gets down to the nitty-gritty of, I have computer-based training. It's simply text. Not everyone learns that way. Some people learn auditory, some people are visual, some people have to do. Some people can read it off of text. But unless you're looking at those things within a training program, somebody may have the best of intentions, but they cannot learn that way. So what can you do? I mean, from my perspective, what it comes down to is, what story are you trying to tell? What are you trying to tell management? Metrics can tell all sorts of stories. Be careful that it tells the story and triggers the behavior you want it to trigger. I've seen all sorts of interesting metrics. I almost got into it with a senior VP about 12 years ago because there was a metric that somebody invented a metric. I was running the training program. Somebody invented a metric that was going to put all the senior VPs on a dashboard and what percentage of their people were either registered for a training class or had completed. And this one senior VP is like, I am going to be top on that board. So she sent an email out to all of her employees that says, if you cannot complete training by this date, register for a class. I don't care if you can get in it. I don't care if you can attend it. Everybody has to be registered. So what happened was I had classes in Brussels. And I had a bunch of people in the US load up the class in Brussels so that the local people couldn't actually register and attend because they were following their senior VP's edict. Because somebody made the metric that said, hey, we're going to have these senior VPs compete against each other. So be really careful what story you want to tell. Thankfully my boss kept me from getting fired on that one. Clean and accurate. You wouldn't believe how hard that is. A bunch of the data I got for the top 10 stuff, there were more, the incidence rate was higher than the number of apps that they actually tested. Like, how did you find 900 unique stuff in applications when you tested 600 apps? Like, this is just basics. I don't get it. Write stories. That's really my super short way of trying to figure out how to condense the whole move left and all of the rest of the stuff of don't try and test yourself secure. It doesn't work. Figure out how to build the program. Figure out how to build a story so that you know at any given point in time how your app's doing. And then consider contributing. I mean, one of the hopes I'm taking a break from the top 10 right now. I have a feeling I'll get back into it for the next cycle. One of the hopes is to build a data collection system that people can contribute, even if it's their own data, and they don't have to worry about that being exposed. So, but that's what I got right now. But not to stand between you and barbecue, since they're letting out and...
I'm going to do a real quick house cleaning. I'm not going to clean the house. My wife knows that. Brian, thank you very much. I appreciate it. Josh Adams, I got something for you, my man. All right, you are one of our winners today.